I am recording the event, okay, for the sake of having this with us, okay? So, and there are many students incoming here at this moment. They are all joining us. So I will make Kyle also a presenter because he has a presentation, and also I have Rommel. Let me make him also a presenter. Ryan also a presenter in their respective time, no? In their respective time. And I have Danielle, Loremi, which is here as well. Loremi. So we have about a group of students that are incoming. Christian, Celine Menendez, I can see them. I don't know Alexandra, number 2. Alexandra shall be from the group of Machimar, Dr. Machimar. And so she may be in that group. Okay, and so, I'm trying to. Angeline, good afternoon. Yes, I will make Emily correct. Okay, Angeline, I will clear that up. Okay, Angeline, let's see. Thank you for letting me know. And Raynel, no, Emily, presenter, correct. And Raynel, no, and Raynel. Okay. So they have also the privileges of presenters. We have Celine Menendez. We have Crystal Sanchez. We have Ryan. I don't know. Christian. Let me know. What's your point? I can hear you. Why not? Loremi Ramirez, Rianet, Crystal Sanchez, Kathleen Hernandez, Jorge Jose Diaz, Isabela. I think somebody raise a hand. Okay. She will be. Angeline, wait for the moment that, and Emily, wait for the moment that your presentation is announced so that you can share your screen, please. We're going to have a group of presentations, correct? So good afternoon, dear students. This is 3:30 p.m. and I am delighted to introduce Mark Tirpak from the Earth Ethics Institute at Miami-Dade College. He comes as a moderator for this event to introduce that to you.
Well, I'm delighted to be here too. Again, my name is Mark Tirpak. I work with the Earth Ethics Institute, which is part of change making and social innovation at Miami-Dade College. You might not have known this coming into the room, but this session is part of a bigger online symposium of over 30 events. So you might have some guests in the room with you. If not, we have, it looks like a very robust audience. So in this case, it's going to be primarily students presenting, if I understand correctly. This session, though, is entitled for anyone who is coming from the outside. It's looking at climate change and emissions impacts, and specifically for African nations. Is that correct?
Yes, that is correct.
Okay, good. Well, so I'm going to learn a lot in this particular session. As I mentioned, this is part of what we call at Miami-Dade College a campus learning community, which is a chance to bring together guest speakers, faculty, staff, and almost most importantly, students to talk about interest of topics of their choice, right? And in the last few years, we've been looking at each of the 17 UN Sustainable Development Goals, sometimes called SDGs. This year, students, faculty, and staff decided that we should look at goal 3, which is about good health and well-being. It's more specifically, it's looking at ensuring healthy lives and promoting well-being for all at all ages. So where I can, I'll try to tie the presentations to health and well-being. Before we begin, and related to our work supporting environmental sustainability and also working for health and well-being and positive change making, I'd like to offer a land acknowledgement. The statement that I'm about to share was developed in consultation with Houston Cypress, who's a member of the Miccosukee tribe. If you haven't experienced one of these before, a land acknowledgement, land acknowledgements are a way to help strengthen relationships and show awareness of the known history of human settlement where we currently meet, and of the people who have been and often continue to be the stewards of this particular land. Moreover, this statement that I'm going to read is intended to extend respect to anyone who might be with us today who identifies as Native or Indigenous. I'll just read from our statement now. I'm sorry I don't have it memorized. At Miami-Dade College, we acknowledge the indigenous peoples on whose land we gather, the Miccosukee and Seminole tribes who remain unconquered, and the Tequesta tribe who first occupied the land that is now downtown Miami, and so represent ties to both our prehistoric and historic past. Miami-Dade College is grateful for the unique knowledge and ways of being, as well as the profound connection to our South Florida ecosystems that these indigenous tribes represent. We look forward to strengthening our relationships with both Miami's indigenous peoples as well as the natural world. So thank you for allowing me to share that. Before I hand things back over to Professor Bestard to guide us through the different presentations, I just ask that everyone try to be courteous in the chat, but to definitely make this fun and interactive, please. I mean, we're in the afternoon, so please jump in with your questions and comments. I'm going to, though, try to limit my questions and comments to make more space for you all, but I will be posting in the chat some links to more information about our work at Miami-Dade College, but also a link for you, if you could, to record that you were here at this session, especially if you're from another class and are trying to do, and are doing this for extra credit. So I'll put those links in the chat. Thank you very much for your time, and I hand it over to you, Professor. Thank you.
My pleasure, Mark, and I am very glad that you brought the statement about our Native American founders of this land, which is very important. And as you mentioned before, this is a session that deals with the climate change in this symposium that is college-wide. And this is part of that symposium. We will have 7 projects presented here and a group of students that are attending, and will be in each of the cases, we will have 1 or 2 presenters per project, and we will have some other members of the team attending the chat to answer questions that you can type in the chat meanwhile the presentation is ongoing. Every presenter will have about 5-7 minutes to present, and then we will have 7-8 minutes more to discuss the work if necessary. And so basically this is going to be organized, the organization of every single presentation. You need to wait till your project is announced by me in this order, no? And so, Mark, you have your hands on.
I did, and I'm sorry if I'm muted. Oh, I'm not muted. Oh, good. Look, and I just answered my own question. I'm so sorry. I just wanted to make sure that we were recording the session in case anyone wanted to watch later. And I see that you're doing that.
I am recording that. No problem.
Too much coffee. I'll put myself in the background again. Thank you.
Not a problem. Okay, without any hesitation, what is important is that if you need to mute yourself and unmute yourself when you consider after the presentation to talk, raise a hand, and I will be more than glad to give you the word after the presentation. So every project will present. After the presentation, you may raise a hand or type your questions during the presentation on the chat so that the co-teams, the members of the team can answer your questions down the road. Okay? Is everybody clear on that? So without any more delay, I would like to introduce the very first presentation by the methane CH4 emissions globally by the corresponding team of Emily Martin, Angeline Gonzalez, Lindsay Vasquez, and a group of more students that are co-teaming in that presentation. So Emily, Angeline, Lindsay, the room is yours. You may share your poster and explain your findings. Okay. Remember that you need to unmute yourself. Here, can you share now?
All right, can you see the presentation?
Yes, but okay, can you make it a full screen if you can?
Is that better?
Now,
Okay.
much better.
Perfect.
Much better. Thank you.
Well, my name is Annalise Suarez, and today me and my group will be presenting the CH4 emissions globally and how to reduce them.
Okay.
Introduction. CH4, more commonly known as methane, is one of the many greenhouse gases in our atmosphere, contributing to global warming. CH4 accounts for about 10% of our atmosphere's greenhouse gases. Though this is a small amount in comparison to CO2 levels in the atmosphere, CH4 traps radiation for longer periods of time than CO2. The radiation trapped in this gas causes our atmosphere and oceans to become hotter, leading to the depletion of the ozone layer. 50 to 60% of this methane is due to human activities. Due to this, we want to focus on minimizing the amounts of methane produced by human activity. Where does CH4 come from? 50 to 60% of methane comes from human activities, the majority of this being agriculture. Waste produced in homes/businesses and energy sources. Agriculture mainly consists of waste produced by animals like manure or their digestive patterns. CH4 is produced in various farm animals, goats, cattle, sheep, etc. Though manure and digestive processes energy sources like petroleum and natural gases have CH4 in them, which lead to methane seeping into the atmosphere while people work with those energy sources. Lastly, home and business waste includes landfills, which actively produce methane as the waste decomposes.
So in the chart, the global CH4 emissions, these are the levels of the CH4 in parts per billion globally. As you can see, there has been a major increase of CH4 from 1987 to 2016. There were a few drops in levels from 2001 through 2002 as well as 2005, but overall the levels of CH4 in the atmosphere have continuously risen and will continue to rise. These are the several leading causes of the CH4 levels in our atmosphere. These include coal mining, manure, natural gas, petroleum systems, landfills, electric fermentation, and more. The most prominent cause is natural gas and petroleum systems, which is, as you can see, 31%, as well as the enteric fermentation, which is 27%.
How can we reduce CH4 levels globally? We can reduce methane levels by altering certain aspects of agriculture and livestock production. One thing farmers can do to provide animals with more nutritious diets so they can be more productive. Scientists are experimenting with food to try to limit the amounts of methane gases that are released by animals. Another approach can be to irrigate and drain fields multiplies times a season to limit methane production. Coal mines and waste plants can also trap methane and use it to generate electricity. The help of new emerging technologies can also create new solutions to reduce CH4 levels globally.
Conclusions. In conclusion, it may be impossible to completely eliminate methane from our atmosphere, but we can most definitely reduce its numbers. Many scientists report that methane levels can be cut down by 57% by using already existing technologies. Methane traps in heat. Methane traps in heat in our atmosphere, which contributes to global warming. It is important for people to become aware of this issue because small changes can make a big difference. Reduction of CH4 levels in our atmosphere will ensure a more safe environment and a better place for the world. Thank you.
Okay. So any question from the auditorium, please? Anybody want to raise a question? So is there anybody having any question related to the presentation?
Just a great comment. I'm so happy that you took a look at methane. If you're following politics right now, what COP26 just took place, which was a gathering to look at issues of climate crisis. The U.S., along with other nations, made a major commitment to reduce methane. In particular, I love that you're looking at issues of how to reduce methane through things like even animal feed, what we eat. Just really happy for it.
I think it's an excellent presentation. I wonder if they observe in their search, and I wonder if they observe in their search any use in terms of producing energy from this accumulation of gases. Did you find out any interesting source that refers to that in your project? To the presenters? Can you answer that? Did you find any? Yeah. Oh, this is a question. Can you explain more about, Kyle? Can you repeat the question, please, so that they can see it or say it? Please do not hesitate, Kyle, to announce the question. Kyle?
Yeah, so my question was, can you explain more about how animal feed helps like combat climate change? Because I'm a little confused about that in particular.
Okay. Okay. So to the presenters. Any presenter? Emily and Angeline, Lindsay, can you answer the question? They are mute. What about the question that Kyle asked?
Yes, we're here. So pretty much the food that the animals eat, when it's digested, then the particles after it goes into the air. So if we manage what they put into their bodies and we feed them more natural sources of food, our air will have pretty much more.
You were cut, Emily.
Kyle, along those points, I'm the least scientific person in the room, right? But my work is challenging me to learn. Part of this is flatulence, farts, like trying to keep animals, what they eat affects how they digest and what's released as emissions. One of the most interesting things that I've heard recently is looking at transitioning more cattle, which produce a lot of methane, towards kelp-based diets. Kelp is, seaweed. It's something where the seaweed, there's a lot of benefits in seaweed as being a carbon capture too. So it's kind of like, it's kind of funny, but it's also just, it's really the scales of these things. I love beef, but I also eat primarily vegetarian. So I'm looking at ways to reduce my footprint with what I eat, but it's also how we raise animals and what we feed them. So, I mean, I wish there was something a little bit not so gross as just saying, well, it's related to their manure or their farts or their emission, but that's pretty much it. If I got it right, I don't know if I get a bonus point for that or not.
That is how. Okay. That is how. And the intensive process of producing animals concentrate them, and they produce a lot of methane in the farms. And so there are areas in the world, in this case, Africa is absolutely completely polluted by these concentrations and by these production of methane from the savannas fires, from the several processes, industrial processes that free methane, that produce the pollution of the atmosphere and contribute to the global warming as well. So any other question from the auditorium? Uh, Thank you for the team and thank you for the interest that the audience demonstrate. And I would like to introduce the second presentation, which is a evolution of the average ice area in the Arctic and the Antarctic in the last 100 years. And this is a topic that is developed by Madeleine Perez, Jennifer Thames, uh, 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 Cristobal Ramirez, and I think I don't know if I have given them the privilege to present. So Rommel Calderon. So Rommel, are you ready for that? Can you present, Rommel?
Yeah, yes, sir.
Oh, okay, okay. You have a privilege of presenting, Rommel. Can you?
Let me check.
If you have the if there is any other member of a team that is able, Sarit, for example, let me give their I don't know if there is uh, in this moment connection for her. Let's see. Uh, uh, any other member of this team? The average eyes. Rommel, ready? Mhm.
Yeah, sir, just one moment.
Can you share? Uh-huh.
Uh, um,
Miguel, Miguel Gonzalez, can you help him? Just in case we have the possibility to expedite this one. Uh, Cristobal Ramirez, Cristobal, can I give you presenter privilege so that you can? Well, you are sharing that whiteboard, Rommel. You are sharing here a whiteboard. Can you share your screen or your tab? So in this moment, Cristobal, you're part of a team. I gave you a privilege of presenting. Please, can you help Rommel?
Yes, Professor.
Check it out.
Yes, Professor. Give
Okay.
me 1 second. I'm trying to figure this
Okay.
out.
Okay.
Yeah.
Appreciate
Sorry
that.
about that. Hello, by the
No,
way,
that's
guys.
fine. That's fine. That's fine. I understand that. Maybe Rommel is sharing the whiteboard, but he needs to share the corresponding tab instead of a.
In the meantime, I'll keep thinking about methane.
So do I. So do I.
Hmm.
Methane is a main biogas, I
Yeah.
think, and it is very powerful from the energy point of view. Okay, we have
Here we
here.
go. Great.
Okay, Rommel or Cristobal, try to maximize in your screen as I did in mine. Correct. I don't know if everybody could see that I maximize in the left top corners. You have a lens with a plus. You can
well, I
click
was
there to
able.
maximize so that people can read also in the poster. Okay. This
Okay,
is a presentation about the evolution of the average ice area in the Antarctic and the Arctic in the last 100 years.
so
The room
okay,
is
so
yours.
okay. To begin, we're all aware of the ongoing effects of climate change. It's found in many places, such as in the air and water. But what we often don't realize or don't discuss is the change that it has on our ice caps in both the Antarctic and Arctic poles that are both north and south of the world. Um, Ice caps are very important for the very following reasons. It stabilizes Earth's magnetic centerness, and in the last 100 years, the ice caps have slowly melted into our seas and waters, which has been allowing sea levels to rise slightly over the years. So much so that if in the next few years, many scientists and experts worry that in such as the state of Florida will be underwater and cut off from the mainland. It is a very drastic, and it's a very very important issue that if we do not change our ways and our methods, we will face the drastic consequences that our inability or our inaction will cause if we do not change. Sorry for the background. Let me see if I could. This poster is to inform a normal audience. Can you still hear me? Hello?
Yes, we can hear you.
Yeah,
Why not?
we can hear you.
No problem.
Okay, yes, sorry.
We can hear you. We can hear you.
The purpose of this poster is to show in an artistic way or creative way the research that the last 100 years has provided about the ice caps, the rising sea levels, the increase, the progression that the ice caps have been melting at a very drastic rate. Each year, it seems to be increasing more and more. And how global temperatures have changed drastically in the last 100 years for the two regions, the Antarctic and the Arctic, Antarctica and the Arctic. Our findings consist of yes, of course. Sorry, I just got. Our findings have consist that since 1979, particularly in the Antarctic sea level, the sea level around the Antarctic has risen by 1%. Which sounds small, but it is very large in a much larger scale. 1% of rising sea levels in around the Antarctic would consist of for the rest of the world. It limits, and with rising sea levels, it limits the mainland. It limits particularly islands that are surrounded by bodies of water, and that if we are not careful, it will be engulfed in water, which means that land could in another 100 years not even exist, and it will rest slowly. It will rest quietly at the bottom of the sea. In that sense, as I mean. Yes. Antarctic typically peaks in ice around the seasonal areas between fall and winter and so forth, which has been increasing very, very much their temperatures, which has not really helped our case. As you can see, there's various graphs that have been showing the Arctic and Antarctic sea ice extent. Sorry, I also meant to say the ice extent also means ice caps. The further, sorry, it's hard to see. I have to increase to it. So of course, so yes, of course, the chart shows us that the sea level has risen significantly, particularly since 1981. 2020, and it shows us how much the ice and sea level, how much the ice melts and the sea level rises in a year, which peaks around October, as it seems, and ends around moderately around in January when the year's up, but it begins all over again. That's the average of what we see. Here in this chart, we see that was the Antarctic daily sea level. I forgot to emphasize that. Here we have the Arctic. The progression of their ice melting, their rising sea levels. Sorry. As we can see now, it has drastically decreased since 1984, minimally. Given the fact that climate change and the Earth itself has warmed up, global warming has increased since the 80s to now, and the fact that we still have the fact that the world countries still allow a very unenvironmentally friendly efforts, like factories, like sea pollution. It has drastically increased global warming and has caused devastation in our world's environment, which in turn affects also our sea caps. Everything plays in a part with everything. So while I know I'm only speaking about particularly the Antarctic and Arctic sea levels and sea caps and ice caps, it plays a turn with everything else. So if we do not fix this problem here, or this particular problem, then we can't help fix any other problems like air or sea pollution, as I've mentioned before. And here we are in conclusions. This is actually something I wrote. I essentially said, sorry, I'm trying to, I guess, I'll just read what the conclusions I've stated. With the support of statistics provided, we conclude that the most affected ice area in the past century was the Arctic and Antarctic. My apologies, because it is more sensitive. It's more sensitive now than ever. Forgot to add that part. Ultimately, with the rise of the sea level in the world caused by the melting of the ice caps from the North and South Pole, we humanity are in critical danger from not the sea or the ice, but rather ourselves. The more we abuse this planet of ours, the further cements our future destruction. All the statistics and factual information will lead to the inevitable conclusion that the amounts of carbon dioxide and other greenhouse gases we emit constantly impacting our global temperatures, which impacts our ice areas, especially in the Antarctica and Arctic. Apologies. Therefore, we as a species must strive to fix what we have broken, to usher in a new era of a new and cleaner status of the earth. This isn't a choice, but rather a burden and responsibility, because if we choose to further ignore this problem, we'll be choosing our own annihilation and self-destruction. We change, we must adapt to these changing times in order to have a place in the Earth's future.
Mm-hmm. That's it. Correct, Cristobal.
No.
File. Huh?
No, I apologize.
Oh,
I was sorry, I was interrupted. Sorry, where was I? We will be choosing our own annihilation and self-destruction. We must change in these changing times in order to have a place in the Earth's future. But even that is not enough, not nearly. But it is the very first steps, it's the very first step, not another towards devastation, but peace and environmental harmony. And here are the references that helped us.
all right. Cristobal, did you mention something? As I could see, and then I couldn't realize to read completely. Do you want to say something, Cristobal, in addition to the presentation? Cristobal, okay, go ahead. Go ahead, Cristobal. No, we cannot. We're not hearing you.
Unfortunately, it's sometimes a problem with Blackboard when there's a lot of people in the room. You might have
Yeah.
to leave and come back
That's
in.
why I needed to close the mics in order to save some bandwidth. Mark, I think we are having that problem.
Oh, it could be me.
Hi, can you guys hear me?
Oh, that's interesting. Cristobal, I can hear you, but I believe we've lost the professor. Can other people hear us?
Yes, I can hear you. I can hear you, Cristobal. I can
Okay,
hear
good.
you.
Hey guys,
I am muting my mic in order to save some bandwidth.
perfect. Okay, so what I was trying to say is that fossil fuels is one of the biggest contributing issues to pollution and climate change. Fossil fuels obviously started to grow and become more prevalent as productions of cars, more factories, like industrialization in general, just added to air pollution a huge amount with the ever growing like communities and cities, and everybody getting a car, everybody having a home, a stove, everything contributes to it. And what we want to try to lessen is the carbon footprint, find ways and policies maybe to change that. There's a lot of discussion. It's a very, very controversial topic in the States and probably everywhere, that is like discussed by a lot of people, just what we can do about climate change and how we can try to lessen the damage that we have are already caused and created ourselves, so yeah, that's what I wanted to say.
Correct. I found something. Somebody says that given the fact that the winter and summer seasons are alternating the two poles, the caps can recover from one to another. How about that? Have you heard about that?
Yeah. So in the I'm pretty sure it's the Arctic. In like September, it starts to melt, and then in the winter season it should like again start to freeze, but since it starts melting so much, there's less to freeze, and then it becomes less and less every year, and it looks like it's at an all-time low. I think in 2013 it was at an all-time low. That's when it was like record hitting, and then recently it's been going a little up, but it's not much better.
Oh my God. Okay.
Yeah.
Correct. Any other question, please, from the auditorium? Any other question?
Well, of course, I'm really into these topics. I would just say again, as someone who's not as scientific as you students in the room, the way it's been explained to me is to think of it as all these changes are incremental until they become exponential, right? And we talk about incremental to exponential, like just all of a sudden, and what we're seeing are with these cycles that were, that this group described with looking specifically at the Arctic and the Antarctic. It just kind of it doesn't bode well for in terms of issues of sea level rise for all of us. In fact, tomorrow, Professor Carlos Fernandez will be doing a presentation about sea level rise, and he poses it as challenges and possible opportunities with sea level rise for Little Havana and the Padrón campus in particular. So if you have a minute, maybe check that out tomorrow at 11 a.m. But thank you to this group. Yes,
no,
be there,
we
please.
are in danger. I can see a contradiction that real estate properties are increasing their values in Miami, and at the same time, Miami is sinking due to the sea level rise. Correct.
It's
So
very
That's an
true.
interesting conversation.
Immersed. Eh?
That's
And
very
there's,
interesting.
and there's an issue even, there's new awareness with property technology, property tech, right? Like if you look at property now for sale in Miami with a platform like Redfin, which is one of the new online, not that new, but one of the systems, you can actually look at flood risk. And lately, I was displaced from an apartment. I had to find a new place to live, so I was just checking out what was for sale at the very low end. And what you'll see are properties that are at the lowest end. You'll get a prediction based on like NOAA's estimates of sea level rise, where the flood risk this year is 0, but in 5 years there's a 95% of it flooding. In 10 years there's a 100% chance of it flooding. So that's just becoming every day, just how we're even making like financial housing decisions. So thank you to this group for presenting this. And I'm too into this stuff, even though I'm not scientific. So next group, please.
Okay,
Thank
see
you.
the next group. I have a schedule here. Dr. Mahamdar presentation, 2 presentations in a row. The one that is Bojada et al. With a group of students, and Velasquez et al. From Dr. Mahamdar. Are they around? If I haven't given them the privilege of presenters, please let me know in order to give you the privilege of presenter. If they are among the ones that I already gave the privilege of presenting, please step forward. In this case, a group of Bojada, which is about the burning crops in Africa and contribution to the methane in that region of the world. So are they around? Evelyn Bojada. Evelyn, did I give you the privilege already? If not, let me know in order to give you Evelyn Bojada. Evelyn, let me look for you in the list to give you the privilege of presenting. Evelyn, I will give you the privilege now of presenting. Now you have them. You can share your presentation.
Good afternoon, Professor. Now I can talk. Before the chat was off for me and the microphone, so I couldn't talk. I was like, how am I going to talk now?
Evelyn, you have now the privilege of presenter, so you can go ahead. The room is yours. I don't know, Angel Ruiz is raising the hand. Angel, what is your point?
Yes, could you also make him a presenter because he will share a PowerPoint?
Angel Ruiz.
Yes,
sure. Angel
Thank
Ruiz.
you.
Let me look for him in this list. Angel Ruiz. Yes, definitely. I am making him a presenter. That's fine. You both are presented. You can share. Anybody else you need?
Not at the moment. Thank you so much.
Okay. So we are delighted on waiting your presentation. Okay. In the waiting list are the group of Velasquez and the group of Ryan Albert. Please let me know in the chat if you need to make to become presenters.
Hello.
Okay, but now we're going to listen to Angel and Evelyn.
Yeah, hello. Yeah, I'm asking a question. How do I present my PowerPoint? How do I bring it up?
Oh, you can go to the bottom, expand the purple tab that you have in the lower right corner, and expand that, and you will see a block.
Oh, share content. Okay.
You have a box with a curved arrow that says share content, and so you can share your file, or you have different choices to share your file, your screen, you can share different camera, application screen, whiteboard.
Perfect.
You can share a file like the PowerPoint. Okay. And when you share, you can download from your computer what you have already saved. Okay.
I'm going to.
That is a Mark. This is also a collateral course in Blackboard using.
Okay, I found it. I found it.
So in addition to that, this event has that feature.
It's all fun
There
and
you
games.
go. There you
Oh,
go.
methane, my favorite topic. All right.
Okay, does everyone see?
Yes.
Okay,
Oh,
we can
perfect,
see that,
perfect.
no problem.
Yes.
Great, excellent.
So good afternoon, everyone. My name is Evelyn, and my partner is Angel Reese, and we are
Hello, everyone.
presenting methane emissions due to burning crops in African regions. This topic was pretty awesome because we were able to gather data and understand how burning crops in African regions is a major contributor of pollution in the atmosphere. Um, in the regions of Africa, agriculture is very important. So due to their semi-climate and geographical diversity, burning crops, it's common there. Obviously, not knowing how it's affecting our atmosphere, releasing methane um, emissions. Go ahead, Angel.
Okay, so the purpose of our project was to research methane emissions, for how it's affecting global warming today through different regions of Africa. And as we see here in the graph on the figure 2 on the bottom, where it shows Eastern Africa, Middle Africa, Northern America, Africa, sorry about that. As you see I'm sorry about that. So as you see Eastern Africa, you see how it's on the uprise and it's going straight up. Okay, in the long run, it will continue to impact the climate and air quality, therefore affecting vegetation, soils, humans, and animal quality of life. Not to mention the release of gas emissions such as methane is impacting the atmosphere and increasing mortality rate. Evan?
Uh, in figure number 1, we can see the methane cycle. And in nature, methane is produced by the anaerobic bacterial decomposition of vegetable matter underwater. In the diagram, we can see the methane cycle illustrating the flow of methane starting from the soil into the atmosphere. We can conclude that human activities such as the burning of crops has a lot into what's going on in our climate today, and it will increase it's increasing over the last few years, and it will continue to increase if we don't do anything about it and we don't educate farmers of these regions, giving them options to save our planet. And to conclude, and after of conductive research, methane emissions in these regions will affect us as a society. We will have to be aware that these emissions, these gases, are killing our animals in our ambience. So I, ask everyone to, share this and educate people so we can all be in this planet for more years to come. Thank you.
Save planet Earth. Yes.
Okay, anything else, Angel?
No, just to save planet Earth. I hope everyone has seen this presentation and understand where we're coming from, and we hope for everyone to get a better perspective on burning crops in Africa regions.
So this practice sometimes is a very frequent practice in extensive agricultural systems. Burning crops eliminates residuals from previous harvest, and at certain point, I wonder, is there any indication in the literature that you consulted about the use of this energy that the crops, the residuals can have? Is there any indication of the use of that energy rather than to free it to the atmosphere? Because some of them, maybe some agricultural residuals can be used as a feeding other animals, but also as energy producers. Is there any indication that you found in the literature?
Really, as I was looking through everything, I really don't know
Okay,
how
no
to
problem.
respond to that
Not,
question.
okay,
Yeah, I
no,
really
it's
haven't
just
found
an
the solution.
observation. It's just an
Yeah, I haven't
observation.
found a solution. No.
So I want to say something. So when
Uh-huh.
we burn crops in the soil, um, this practice is for them to replant again. So if
Exactly.
there is energy, that is why back in the day and still today we use it because it burns everything out and it creates that the soil comes back again. So we are using energy there. But what's happening is that we're not doing it consciously because there is ways that we can use it where the emissions can be lowering.
Controlled.
Yes, controlled instead of doing it massively without any
Yeah.
way to control it.
Well,
So
in
we are
main,
using the energy.
correct. They are not using that energy. In particular, in those countries of Africa, which some of them are really poor, maybe the use of such residuals could feed other animals and could increase the cattle yield and the cattle production by having, in particular, in times of droughts that they
Mhm.
suffer frequently, it could be a good choice of feeding other cattle, correct? So I
Correct.
always think about that because in many countries, the residuals of previous crops are used as energy and as source of feeding, a source of protein or fiber to the corresponding other kind of cattle. Okay, but excellent
That's
presentation.
correct.
Thank you. Thank
Thank
you
you
for
for
your
your time.
presentation. Any other question from the auditorium, from Mark, please?
Come
Any
on,
other
students.
question? Come
Anybody?
on.
I have a statement or just an idea, but it's more this
Yeah.
this thinking of like that the professor's getting to closing loops. Like it's not just in rural regions of Africa where we can be thinking like this. Like I lived in Texas, right? And one of the things that would happen in the oil fields there is the flaring of natural gas, just because there wasn't any economical way. uh, Nobody could figure out a way to make money from just moving that fuel to market, right? And like visitors from Japan would come over and just be just gobsmacked by the burning of natural gas because there just wasn't that kind of thinking of well how can we better use this. But it's another passion of mine is thinking about the waste from palm trees. I've lived in California and now here. In California, people are actually converting palm tree waste into feed for cattle, right? I mean, here
Wow.
we just pile it up and somebody comes and picks it up every week and it goes, we don't know where, because it's a really difficult product once it ends up in landfill. But thinking about thinking differently about waste is really valuable. That's all I have to say. And I appreciate the professor trying to lead questions there. Thank you.
No, I
Well,
just
no, thank you so much for
Thank you
that
so much.
point of view. And I also wanted to share, there is mitigations that farmers can do to minimize the degradation, and help the environment, but also use that as a benefit. Um, so thanks for sharing that.
Well, thank you for your
oh,
research and go Hialeah.
yeah, go.
Yes,
I have a T-shirt.
thanks.
Somebody from the Hialeah sent me a "I love Hialeah" MDC shirt, so I wear it on the weekends. I can't wear it around Padron; they'll kick me out.
Thank you so much for everyone's time. Bye.
Thank
Okay,
you. Thank
thank
you so
you.
much.
Thank you for your presentation. Take care.
Mhm.
Well, what about next? Velasquez? Is there anybody from the team of Velasquez here? Did I make them presenters already? Velasquez from Professor, from Dr. Mahmdar. Is there anybody here in that presentation? Otherwise, I will move forward. If anybody from the team of Velasquez in the Savannah fires or production of methane. Is there anybody else in this room that needs to be awarded that needs to be granted the privilege of presenter? Okay, if not, I will in the meantime. Christian, your point. Christian, you are in that daily, so you need to be presenter. Can you let me know? Daily. What is your point,
Professor,
Christian?
you have to unlock their microphone in their chat, like you did with me last time.
Okay. Let me daily, and who is the other one? Who is the other one? I lost him. Daily here. Let me make a presenter. Okay, now is presenter daily, and the other is what is the other that raised a hand? Christian A. Okay, Christian A. Let me see. Christian, lower hand, two more. Let me know. Kathleen Hernandez, number 2. Let me make her a presenter as well. Daily, I already made you presenter. Daily, Kathleen Hernandez.
Okay, teachers, Daniela, in 5 minutes, please.
Okay. Okay. So I have here Daily and Cristal Mariela Sanchez. Cristal, do you need to become a presenter as well? Cristal, let me see where you are. Let me see where you are here. Cristal, let me make you a presenter. Okay, now you are, guys and girls. Please, you can step forward and prepare your presentation now.
Hello, I'm gonna be the one presenting.
Okay.
Oh, showing the presentation.
Okay. Can you share your presentation?
Yeah, I'm gonna do that right now.
Oh, Daniela Velasquez, I have here. I will make her also a presenter. Already made a presenter, so you can all present, please. Okay, great point. So we have some delay here. Okay. You can make a full screen if you click in the slide. Excellent.
Okay, so our presentation is about climate change versus the sunshine state. So I'll start it off by what is climate change / global warming. So global warming is the gradual rise in Earth's temperature, likely due to greenhouse gas emissions and the burning of fossil fuels. Climate change is the increasing alterations of the climate over periods of time, and both affect the world as a whole. But today we'll be focusing on how they affect South Florida and its inhabitants. So Christian is in charge of this slide.
Christian?
Yes.
Christian has his or her hand up.
Yeah, but Christian, I think he's already presenter, no?
No, you haven't. You haven't made him a presenter yet.
Okay. Oh, sorry.
Sorry,
My
Christian.
fault. Sorry, Christian.
Make it more challenging.
I don't see him here. Christian. It should be
number 5.
Number 5. Daniela Velasquez. Oh, wait a moment. Oh, I was looking
I can do it. Should I make them a presenter?
Yeah.
Okay.
If you,
hey,
Christian,
I get guest privileges.
I was looking at the presenter. Sorry for that.
There we go. Can you guys hear me?
Yes.
Sorry, Christian.
Okay, cool. I was a little confused. Sorry.
No problem.
Yeah. Okay. Cool. So as Catherine was saying, our presentation is on climate change and how it affects the state of Florida. So the climate in Florida is changing more and more drastically every year. The water level continues to rise, and the oceans continue to get warmer. This can be really bad news for Florida as well as its inhabitants. Somewhere where it's really apparent is, for example, in the Florida Everglades, where hold on, wait, I have the statistics right here. So the Everglades are currently less than 3 feet above water level, and it just gets worse and worse every year. There are several reasons for this, and humans play a major role in it. So no other species in the history of the planet have ever impacted the climate as drastically as humans have. Since the 1700s, there's been more than 40% of carbon dioxide in the Earth's atmosphere, and the temperature of the ocean continues to warm by 1.5 degrees since the last decade.
Okay, so causes and effects of climate change. Pollution is one of the main causes of climate change, and as its pollutants create a shield around the Earth that is unfortunately make the planet's temperature hotter. This causes health risks as we can only take so much heat before getting major sunburns or even heat strokes. Another cause is transportation. Transportation is a major use of energy, which in turn burns a great amount of the world's petroleum. This in turn creates air pollution and is a significant contributor to global warming through emission of carbon dioxide.
So how climate change will affect Florida in 20 years. So climate change has been slowly affecting Florida, and you can't really tell what 20 years is going to be like. However, we can estimate that Florida is pretty much going to be submerged underwater over time. So sea levels at different points along the coast will likely rise by 8 to 12 inches by the year 2040, which is pretty alarming, not gonna lie. By 2040, higher temperatures are more likely going to cause a lot more deaths, for example, cardiovascular and cerebrovascular disease. Sorry, can't pronounce that word. Our findings also show that hurricanes will become more severe and saltwater intrusion will degrade water quality, as well as disease carriers like mosquitoes will spread. And in a later slide, we're going to go into exactly how the hurricanes and how the storms are going to get more powerful as a result of the climate change.
So how will climate change affect our health? If we keep seeing increasing temperatures, our state will most likely face several consequences. Excessive heat due to these constantly increasing temperatures could claim the lives of at least 150,000 people in the future. The most vulnerable to these temperatures are children, the elderly, and the poor. These exposures will likely lead to the following health-related issues: dehydration, heat strokes, aggravated cardiovascular illnesses, aggravated respiratory illnesses, I'm sorry about that, and in the worst case scenario, even death. So how does climate change affect the economy of Florida? In one hand, if global warming continues to grow and expand, many companies will lose properties and areas of economic development, such as strategic touring points all throughout Florida. On the other hand, the stoppage of global warming damages the income of many companies, as most of them might be industrial, which is one of the main causes of pollution. If these industrial sectors shut down, then many of these companies will face an economic drought, affecting the economy of the state as a whole.
So in addition to how global warming affects the economy of Florida, here in Florida, we are no strangers to hurricanes and tropical storms. One of the most impactful effects of climate change is in relation to its hurricanes. Because the atmosphere is getting thinner and more sunlight is reaching the Earth's surface, our planet's oceans are getting warmer. And as a result of that, tropical storms and hurricanes have gotten significantly stronger over the last 30 years. Specifically, since 1957, the amount of precipitation during rainfall in the state of Florida has increased by over 40%. And this doesn't seem like too much. However, when you take into account storms and, like I mentioned, hurricanes, it can become pretty alarming. More intense rainfall also increases flooding, which is bad news for Florida's peninsula, considering that the sea level rises by 1/8 of an inch every single year. And also like Mark had mentioned earlier, the housing market is also affected by this as well, because a lot of the houses are like susceptible to flooding here in South Florida, and it also like ties back into how it affects the economy as well. Some experts even believe that by the year 2025, the Florida Keys are going to be completely submerged underwater.
Wow.
Wow. Is that the conclusion?
Oh, we have a couple more slides here as well with some graphs. Catherine, if you can. Okay, cool. So yeah, this is just a chart explaining like how the sea level is going to increase, has been increasing in inches per year. So you can see that in 1950 it was, it wasn't so bad, and then by the year once we get to the year 2010s, and like it just spikes up drastically. And you can see the predictions here as well. Like by the year 2040, it's going to be pretty significant just how much the sea level is going to increase every year.
My God. Every exponential. And so
Crystal's gonna present this if she's connected.
let's see. Crystal? Crystal?
Hello,
Hello?
can you hear me?
Yeah.
All right,
Yes.
perfect. Sorry. All right, so these graphs here are basically explaining the data that was previously in the last slide. To the left, we have a histogram, and it is explaining the mean, mode, and median of the data. And it is explaining the increases in the sea levels. Now, to the right, we have a frequency table, and in the bottom is a chart regarding the info on the frequency table. And it is addressing the top, at least, is showing the numbers of the decades which fall under the class, which is in inches. And then in the bottom, you could just see a graph, well, bar graph, to see the differences in the levels, and you can see how drastic the changes have been throughout the years. And then our next slide, which is our final slide, if Kathleen, perfect. All right, so this is just a summary of our work and our research that we've done, and I'll just be reading it out to you guys. So basically what climate change is doing to Florida over the years is due to unforeseen variations in climate. There has been changes in the water levels, temperature, and the damage tropical storms have over our state. To further prove the significance that climate change has changed our state, we have gathered information to show just how massive the development of this change in temperature is. The way it's happening is when it comes to global warming, a major factor leading to it worsening is the carbon dioxide levels and how they have drastically increased in the past decades, even in centuries. In the 1980s, the world had a monthly average of 340 parts per million, and last year we were at a concentration of 420. This excessiveness of carbon dioxide directly impacts the greenhouse effect because since CO2 is a greenhouse gas, a lot of it causes almost a bubble-like phenomenon that traps the sun's energy in the stratosphere, which is the layer in the atmosphere that absorbs the solar ultraviolet radiation. What we were able to collect, like I previously stated, from 1980 to now, the carbon dioxide has increased. Here in Florida specifically, it has increased about 1.2 degrees Fahrenheit since the beginning of the 20th century. The Sunshine State also seems to be warming at an estimated speed of 4 times faster than in the past 40 years, including the previous 100 years as well. Hello?
Yes.
Hello?
Yes. Can you hear me? We can hear
Hello?
you. What is that?
Sorry,
What's
it's
going
not
on?
my, it's
Crystal?
showing that it's reconnecting.
Oh, okay. But we can hear
Okay,
you
perfect, sorry.
and we can see what you're presenting.
Can you hear me?
Yes,
Okay, okay.
definitely.
Alrighty. So yeah, when it comes to the precipitation in Florida, it has reached below average. The driest it has been is June 2006 and 2010, when it was less than 48 inches per year. And the wettest was 60 inches, but that was during 1945 through 1949. Now, when it comes to winters, warm winters in Florida have always been known, but in the past years, they have increased by 3 degrees or more. In conclusion, the information gathered easily shows us the change in climate throughout the Sunshine State. Hotter days have increased the number of hurricanes in more recent years, fewer nights below freezing, and increased precipitation. And then here in the middle, as you can see, we have some graphs showing the data. On the first chart on the top left, it is explaining the number of very hot days with the maximum temperature above 95 degrees Fahrenheit. To the right of that chart, it's showing the number of nights below freezing, and the minimum temperature is set at 32 degrees Fahrenheit. And in the lower left corner is an average of the annual precipitation, and the last chart is showing the total number of hurricane events averaged over 5 periods. And that's the whole presentation.
Okay, great. Any question from the audience? Is there any question from the audience? Mark, do you have any question?
Oh, just that this is, I mean, incredibly heavy information. I'm
Yep.
so glad that you shared it. I mean, it's a lot to think about. Good, somebody else. Let's see what Sandy says. Is on average only about 4 feet above sea level. Yeah. And Broward County is only about 3 feet above sea level.
Yeah. Sandy Castillo put that in the chat. My
Yeah.
goodness.
It's very true.
My
And it's an interestingly flat city. Like I'm riding a bike a lot more.
They don't have records on Hialeah, no?
And like dry weather flooding that we're experiencing. Here we go, Kyle. Yes. Yes. He's very surprised to see how much hurricanes are affected by climate change. Yeah. I mean, it's just this intensification of everything that we already know.
Yeah, it is very alarming information, especially when you realize just how close to home it hits, you know?
Absolutely. Absolutely.
Yeah.
Absolutely, Kyle. You're right on that. It's concerning, it's very concerning. For that reason, all these events that have been occurring very frequently nowadays, now that we are exiting the pandemics, many people are taking the stake globally to pay attention to these issues of the climate change, which is, in my opinion, more than concerning, alarming, correct? So this is how it works. Any other question from the audience? And thank you to the presenters. Okay, great presentation.
Thank you so much. I would like to give a quick shout out to Mauro, who really helped to make this entire presentation possible. Unfortunately, he couldn't be here today, but he played a big role in making this presentation possible. So I'd just like to shout him out real quick.
Who is that person?
Mauro.
Mauro. He's in our math
Mauro
class.
Fiol.
Yeah,
he told me that he had to work this afternoon. Okay.
Yeah.
Thank you for letting me know that. Okay.
And I'm doing this just as a favor for learning resources. And as we're approaching the holidays, don't forget that with NBC, you have access to an online kind of sort of more academic Netflix. It's called Canopy. It has all sorts of films that you can access with your login. This is a Nova, which is a PBS production called Decoding the Weather Machine. We screened this last year as part of our campus learning community. As somebody it's been too many years since I've been around a science lab or any kind of what you're doing right now. It's been too many years, right? So this film for me, or for people in your lives who might be really confused about climate change, need some more proof, need some more discussion, this is very digestible. This is a great film to share. You know, I'll probably watch it again this winter. Why not?
Exactly. Excellent point, Mark. So, if no other point to this uh, uh, audience, I would like to invite now Ryan with the team in order to present the carbon monoxide in South Africa emissions in particular. Correct, Ryan? You can go ahead and present.
Yeah, I'm
With the
here.
team.
Yeah.
Okay, excellent.
Quick question though. Let me hold up. I'm trying to see if some people from my group are presenters, so
Okay,
they could at least
okay. Let me
hear.
know. Let me know if I need to
Uh,
make any other presenter.
yeah.
Uh,
Could you
I'll
put
put
Patricia? Oh, what?
Patricia Llerena. Patricia Llerena.
Carlos. Yeah.
Patricia Llerena.
Carlos
No?
Lopez.
Carlos
Yeah. Yeah.
Lopez. I am making Patricia, Carlos Lopez, Carlos Daniel Lopez, no?
Uh,
Making him a presenter.
Car.
Uh-huh.
Yeah. Carlos Lopez. Asia.
Asia Passarini. Correct. Excellent. I
Yeah.
make her a presenter. Uh-huh. What else?
Anitza.
Anitza, okay.
Yeah.
Anitza Contreras, correct. I make her a presenter.
And
Okay.
and Cecilia Perez.
Cecilia Perez. Cecilia. Maria Perez Valdez. Okay, here I am. Uh-huh. Correct. They're all
All
set to present. Uh-huh.
Okay, all right, I'm gonna share the content now.
Correct. Great. Excellent point. The floor is yours.
Okay, are you able to see the PowerPoint?
Yeah. Yeah, you just need to make it full screen.
Okay. Is this much better?
Much better.
Okay.
Slideshow. If you click in slideshow from the beginning, I think it's gonna be.
There, I got it.
Uh-huh. No, it's still from the current view from start. Uh-huh. Can you click over again or from the current slide, please? Clicking current slide from the current slide. In order
Oh, from current slide. Okay.
Uh-huh. 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 Maybe I don't see any change in there. I don't see. Maybe if you make it full screen, I don't know.
Because it's in full screen on my, because I made it full screen, so I'm not sure how it's not working for you guys.
Okay.
It says presenter view on the right. I think maybe that can work.
Uh-huh. Uh-huh. Presenter view.
Presenter view.
Okay.
Is that fine?
View. Well, no, 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 no. No, it doesn't. But it's a minor scale again. You can run the slide from moving one slide to another. I
Oh, from the
don't
side.
know.
That is if that's fine with you.
Yeah, maximize. Uh-huh. Okay. No, it's too big. Too big. Too big. Let's make it 100%. Uh-huh.
Okay.
Uh-huh. Oh, no, make 100% and then
And let me go
I
to 150.
don't
Is
know
that
why
if that's
I
fine?
don't know why it's not working. I don't know why it's not working because it should work. Hello. Oh yeah. Wait a moment. Ryan, try to make it to make it. Daniela, let me see. Daniela. Can I please know what time? Yes, yes. I called you already, but nobody answered, Daniela. Uh, uh, you can go after this one because I was calling, correct? So it may be approximately in 10 minutes after this one. Okay, Daniela? I'm sorry for that. I was calling
Made it a little bit.
and nobody answered in that team.
I was able to make it a little bit bigger to 108%. So maybe is
Okay,
that better
so
or
slide by slide from the side, correct? If you cannot find any other way, go
okay?
ahead.
Okay.
Yes,
How
good
better? All right.
afternoon.
So today,
Oh, well,
now you go.
okay, thank you. Good afternoon. So our group consists of Ryan, Patricia, Carlos, Asia, and Cecilia, and we decided to focus on climate change. The information we gathered relates to the amount of methane emissions counted in the thousands that have occurred in South Africa from 1970 until 2018. These emissions are very harmful for the environment because they trap heat in the atmosphere and contribute to climate change deeply. It is important for all human activities that contribute methane to the atmosphere to be conducted in ways that reduce their methane emissions. This way, we can help reduce the carbon footprint created by humans.
Maybe you are a little bit close to the mic. Can you separate a little bit the mic so that we can hear better you?
Can you hear me?
Now we can, but if you start talking, maybe it gets very close to the mic, and then it gets diffused the voice.
Okay.
Now
Are we
in that
again?
way.
Okay.
That's fine. You can continue.
So it is important for all human activities that contribute methane to the atmosphere to be conducted in ways that reduce methane emissions. That way, we can help reduce the carbon footprint created by humans.
Mhm.
Go back to purpose, friend. There. So I'm Carlos. I'm presenting this part. So the purpose of this analysis was to visualize the effect of methane emission that has on climate change. We all know that that the major source that is creating the climate change is carbon dioxide. However, methane is something that we cannot outlook. It's very is following carbon dioxide and causing damage just as much. Methane provides a great environmental benefit, producing more heat and light energy by mass than other hydrocarbon or fossil fuel, including coal and gasoline refined from oil, while producing significantly less carbon dioxide and other pollutants that contribute to smoke and unhealthy air. This means that the more natural gas is used in place of coal to generate electricity or instead of gasoline to fuel cars, trucks, and buses, the less greenhouse gas emissions and smoke-related pollutants are produced. However, methane is released into the atmosphere before it's burned or is harmful to the environment, as I said. So what we find around the South Africa part is that there is emissions that are content 2000 that have occurred in South Africa from 1970 until 2018. The data chart and had randomly collected and organized the data within stem and leaf display shown below. As you were saying, the stem number 4 for the first graph has majority of the leaves when compared to 3 and while to 3 and 5. While 5 has the lowest amount of leaves in the first graph, the number on the leaves are supposed to represent the number of methane emission in thousands, while the graph below is supposed to represent the days in which methane emissions were produced. The trend of the graph is focused more on the stem numbers 3 and 4, while stem number 5 is less focused. So as a result, it's mostly focused around the left side of the graph. This means that the amount of emissions in towns has mostly been focused around 30 to 40,000. This graph, when compared to the global amount of methane production, shows that there has been an increase in the amount of methane produced globally in South Africa. So in this graph, you can see how the number of emissions produced in thousands. The whisker represent the minimum and maximum of the graph. Qualities number 1 and 3 are both supposed to represent the median for the bottom and upper half of the data. The image tray is supposed to represent the info gathered from the research. The blue bars represent the amount of carbon emission that has happened from 1970 to 2018. It's really hard to see because you cannot like really see the numbers, but around the 96, 1988, 1986, around those times, the emission was really high, and the numbers are going up again. So, no, this part is for Cecilia.
Okay.
Can you hear me?
Sure.
Hello?
Good, good.
Yes,
Yep.
we can hear you.
Do you hear me?
Yes.
Okay. So the graph found below is supposed to represent the amount of methane emissions in South Africa from 1970 all the way to 2008. And in the graph, you can see each year with the representation of methane emissions from the period that I said before. Brian, okay, thank you. So in the previous slide, there was a box plot, which is supposed to represent the number of methane emissions in thousands. The whiskers located on the numbers 31 and 50 represent the minimum and the maximum on the graph. This box plot can be seen screwing more in the right, but the main box is located around in the middle. The shape of the distribution can be seen as being on the center of the graph, while the median is skewed to the right. Quadrilaterals number 1 and 3 are both supposed to
You were cut.
Yeah, because the PowerPoint, like, it
Oh,
stopped
okay.
showing.
Okay.
Maybe it's my internet. It's really bad. I'm sorry.
No problem. I thought it
I
was
only see you right now, Mr. Adams. Okay, I see the PowerPoint now.
No.
Okay, so quartiles number 1 and both are supposed to be represented the median for the bottom and the upper half of the quartile. So the conclusions are that from 1971 to 1989, there was a slow increase in the number of methane emissions that were in Southern Africa. The rise will stop, and from 1989 to 1990, there was a dramatic decrease. There will be another dramatic drop from 1994 to 2001. From 2001 to 2002, there will be a dramatic increase again in the number of methane emissions that are produced. As of now, there has been a slow, steady increase of methane starting for 2001 and 2018. The trend of the methane production that is occurring in the Southern Africa is gradually rises for years and then makes a dramatic decrease and then a gradual decrease later on. When methane emissions reached their absolute highest peak was in 1989, in which it reached 50,800 emissions, and the lowest amount of emissions it received was in 1971, in which then it reached 31,853 methane emissions. Reduction strategies include preventing the burning of fields after harvest, like it was said in the previous presentation about the burning of crops, and adjusting feed for livestock so that they release methane less and more.
Any question? Any question from the audience? They have already posted a reference in the PowerPoint, so you can ask any question to the team that is already on position to answer your questions. Any question? Mark, do you have any observation?
I'm just, because I'm visiting, I was wondering what moves students to really focus in on Africa as a region. Was that selected by the professor, or is that just out of interest?
Well, I think it was a selection that Dr. Mahumdar suggested. So for that reason, they concentrate in the continent of Africa. I think the position is to move continent by continent, semester after semester. Correct? This is a philosophy that he has. For that reason, you are observing now the concentration in Africa. Correct? That
That's
is
very
how it
good.
works.
And it's obviously all of these, I mean, it might not feel like it, but all of these presentations thread together.
Are related to Africa, right?
Yeah, yeah.
And it's a presentation that also is interdisciplinary. So chemistry students link to mathematics and statistics students. And so this is the one that we have. I think we can move into the next one if no questions, correct? So in this case, Natalie, are you ready? Natalie? Natalie? Let me see. Let me see. She was claiming. So Daniela Velasquez. So let's give the floor to Daniela. Please, Daniela and your team, you have privilege to present already. So Daniela, you may produce your presentation, please.
Yes. 1 second.
Okay. Daniela make a great effort coming from work or inside the work, looking for a break. And I really appreciate her commitment and the team commitment in this case. She's presenting on behalf of Daily Pino,
Yes. Yes.
on the advisement of Dr. Mahundar. Okay?
So good afternoon. We are the group for Organic 2, and the topic is methane gas emission due to the savanna fires in Africa. Those who are going to present is going to be Daniela and Daily.
Thank you. And daily, the savanna fires contribute to the increased low layer ozone and other polluting gases. Every year, the residents on this region of Africa burn thousands of hectares of savanna to free the land of hectares of the including pasture. The fires generate many fuels and biomass burning that are displaced at great distances by the prevailing winds. The purpose of about is to share how the greenhouse gases are affected each day more since 1990 until now. We have been suffering our planet, our climate, our forests. Around 64% of the global extent of the area is burning annually. Areas so large that they are visible from space as regular burn in the African savanna, so that NASA scientists refers to Africa as the bird centers of the planet. If we don't stop their fires, damage caused the release methane will continue to affect the entire ecosystem.
Okay, so as you said, the methane is a colorless, flammable, and not toxic gas. It's considered a relative potent greenhouse gas that contributes to the planet's global warming, and it has a warming potential greater than carbon dioxide. However, the amount of the carbon dioxide in the atmosphere is significantly higher than the methane. For this reason, it's considered the main gas responsible for warming our planet. As we can see in figure number 1, these are the 4 major greenhouse gases, which are carbon dioxide, methane, nitrous oxide, and fumarate gases. Although carbon dioxide is the one with more emissions, methane is the one that is affecting more the global warming in our forests. Methane, which is CH4, persists the atmosphere about a decade, which impacts the global warming 25 times greater than carbon dioxide. Looking at figure number 2, we can see the total methane emissions in different African regions due to the savanna fire from 1990 until 2020. We can see how CH4 has been increasing through the year from 22 kilotons to 1,600 kilotons. affecting the heart of Africa even as smaller the emission is. It keeps affecting if we keep not doing anything in some years Africa will not exist or will not be able to habitat animals, trees, and humans. It will be only ages. In conclusion, the concentration of methane, CH4, is a gas responsible for 16% of greenhouse affecting emission, which is causing all these factors in the central of Africa, the area of the world with the most fires, and this has a climate repercussion. The world that burns the most annually is in the heart of Africa and surrounds the Congo Basin, where the second most important tropical forest in the world is located. Although fire is not a problem, the drought drying the tropical forest is. In other words, methane is affecting global warming in Africa. In this one, is receiving all these effects of methane. We must start and it must be now. Thank you.
Thank you.
Okay. Any question related to this? Daniela? Anything else? Daily? Anything else that you want to put in the floor? So is there anybody? Is there anybody asking any
No.
question?
No, thank you.
No, I
Right.
just want to say that our professor Mahunda did a great
Dr.
job
Mahonda.
doing this project. We learned a lot about methane emissions, and sometimes, you know, as life comes, we don't realize what a big problem we have today in this
Some
generation.
people, let me tell you, some people don't see that much problem in this generation. In some places, the methane is accumulated as a biogas to produce energy and to produce other compounds, you know, to enrich other sources. So the problem is to how to integrate the systems, you know. At certain point, you are right, and I am pretty sure that the professor has developed an excellent course in the global sustainability and earth literacy component. Correct. Thank you for your presentation, Daily and Daniela. A great presentation, and we appreciate your commitment. Okay.
Thank you.
Thank you.
Thank you.
Thank you. So I have another presentation on the batting cage, waiting for their turn.
Here we go.
So they're coming now, and actually, I think they're coming. So I think Michael and Mary, are you going up? Ready? When you wish. The floor is yours. Okay, this presentation.
Hi, Professor. So, we also need Ashley to get
Ashley Joseph or Ashley Astorga?
Ashley Astorga. She's the only Ashley in right now.
No, because I think that I will make her a presenter. Is
Thank
there
you.
any other Ashley? No. Correct. So she's now a presenter as well. Thank you for letting me know. Mary. Okay, and Michael as well. You are a presenter.
That's okay.
Correct?
Thank you.
Do I have to share my video for?
Well, you may share the presentation. You have that power in this moment. You are the owner of the floor.
Yeah, but the presentation, how do I?
Oh, okay, go to your left, to your right bottom corner when there is a purple tab, and expand that tab.
The purple tab?
In the
I
lower...
can share it.
Oh, okay, do that.
Okay.
That is teamwork, okay?
Extra point. There
it comes. Okay.
Can you see it?
Yeah.
Yes. Can you make a full screen for the slide? I think it's
Yes.
coming. Great. Excellent point. Excellent point. Okay,
Okay.
see rising levels. Ashley Astorga, Marvin Pereira, Ashley Joseph, and Kate Pusiuk, and Jose Martinez. Okay.
Yeah, we also some of our members are not here today because they had to leave early. But also Michael, he is also part of the group.
Okay, okay, good to know. So
Okay.
you need to include him in that. Michael Caballero. Michael Caballero. Kathleen Pusiuk and Michael Caballero.
So
Okay.
the project is about rising sea levels, and it's a subtopic within the topic of climate change. So sea levels are rising rapidly, especially in South Florida. They're predicted to rise more and more each year, and if trends continue like how they are, South Florida is predicted to be submerged in water in the next couple of decades. So the discussing sea level is an important topic because there's been a lot of disastrous consequences as a result of the steadily increasing rate our oceans have been rising. There's been a lot of flooding, land loss due to the ice caps melting, and coastal flooding. So the Atlantic coast is particularly vulnerable to this due to the low elevations of the land and shorelines that have been sinking. Florida is part of the Atlantic coast, and due to Florida and its coastlines being so low, then flooding and stuff like that is a very big issue. It's very prominent because Florida can be affected a lot by it. So since Miami is on the Atlantic coast, the shores of Florida are particularly susceptible to this. And if trends continue, South Florida will be submerged in the coming years. So here you can see in the middle chart that there's this thing called exceedance probability. So you can use exceedance probability to find the probability that a certain critical value can be exceeded in a predefined future time period. So when a level rises higher than a specific value, you can use exceedance probability to find how likely it is for that value to be exceeded. And within floods and climate change, you can use it by knowing the elevations of the water and seeing when the elevation is going to surpass the values or when it's not going to surpass the values. And you can use the formula 1 minus 1 minus p times n to calculate that value. And so it's a very useful thing because in using exceedance probability, you can see when the relationship between the flooding and the levels that they're going to be at. So you can use the calculations performed to see that there's a higher than normal chance of flood in South Florida with rising sea levels, and it will be prepared for a disaster if knowing these values, because you can use the values. You can see if the values will exceed or not, and you can use them to better prepare South Florida for the flooding. So you can use different types of construction so that the buildings are not as susceptible to flooding and to increased water levels. So in the next 20 years, who knows how much of South Florida's coast will be underwater. So you have to show statistics like this to politicians to enact change so that climate change, specifically the rising sea levels, will not affect us so greatly. And there are the references that I used.
Okay, great. Anything else?
No, I think Marbury and Michael are
Yeah.
supposed to present some of the other slides.
Yeah, so I'm taking over the solutions slides. So with the rising sea level, South Florida is the most at risk for damages and migration of people in the whole country. Solutions have been thought of this issue. An example being found on an article from nextcity.org in which they discuss elevating roads to decrease the flooding of this on the streets. It would make it easier to remove the water from other properties. A road already in the work is the roadway elevation in the Sunset Harbor neighborhood, which was raised by approximately 3 feet in comparison to the residential elevations, which will only be raised between 0 and 24 inches. So building better and bagging seawalls would also help South Florida with the rising sea levels. Seawalls protect areas of buildings close to the coast from tides or waves. More recently, seawalls will prevent minor incidents that could lead to major ones. One last solution to rising sea levels in South Florida is creating better capacity pumps and drainage systems. For years, Florida's government has been trying to improve their systems, but with the expense that comes with it, many challenges have presented themselves. However, if Florida could, the major projects would be the addition of powerful pumps to allow water to be moved to the ocean side of the canal when the ocean is too high to move water by gravity. So I'm just gonna move it to Michael, and he's just gonna ask questions and the answers to them.
Okay, so how are the statistics directly related to the understandings of sea rising levels? Statistics can help the general public to comprehend the dangers of sea level rise by providing true facts and graphics in an easier method of understanding. The sea level changes that affect the coastal systems involve more than just expanding oceans. However, because the Earth's continents can also rise and fall relative to the oceans, land can rise through processes such as sediment accumulation and geological uplift. Another question is, why is the understanding of statistical methods behind climate crucial for the environment? And it's the understanding of climate change statistics brings the greater population a change of consciousness about their planet, and statistics can help a small but still important percentage of people to stop their consumptions of energy and plastic to help the planet. Move to the next slide. And the last question is, what are the impacts that surges and precipitation bring? Increases in the storm surges and excessive precipitation put coastal areas at risk. Storm surges inundate low-lying locations, cause property damage, wreak havoc on transportation networks, ruin habitats, and endanger human safety and security. And what are the impacts on coastal water temperatures? Coastal seas have warmed throughout the last century and are projected to continue to warm in the 21st century, such as 4 to 8 degrees Fahrenheit, as shown in the graph.
Wow. Wow, wow, wow. Correct. Correct. Any question, please, from the audience? Correct. Congratulations, team. You made a good presentation. And unfortunately, I think that Mark and myself, we are concerned and alarmed that we may not see our end of life out of the water. So we may start teaching the dead bodies to swim, how to swim.
Oh, you know, I'm for somebody who works with environmental ethics and sustainability here, I try to keep really optimistic. I know that a lot of this information is really heavy. I do like how I mean, you're entering the students. You're entering this group of specialized individuals within our society who fully understand the math and the science behind this, right? more so than me, you know statistically how to do this, and you'll need statistics like this to do anything deeper with ecology, right?
Correct.
Uh,
Correct.
I, I'm optimistic because I feel like I've been in some like weird and tough corners in my life, and I feel like humans are quite adaptable. If you do watch that Decoding the Weather Machine, I find it a little bit depressing, but it shows where sea level rise is already shaping the community of Norfolk, Virginia, where there's a scene in this film that I won't forget. It's a family that bought a house in the flood-prone area. They didn't realize it, but now they own the house, and there's no selling it because nobody wants to buy a house that's flood-prone.
Exactly. That
So
is going to, yeah.
yeah, they live with it. They drive like this oversized Toyota with giant tires just to get in and out of their suburban area. So the future is iffy. Like there's probably going to be some kind of life in South Florida at whatever rate the sea level rises, but will that be a life that you want? Will that be a life that students will want? It's hard to say, you know, so
hard to say.
A lot to think about. Like, and tomorrow I know that Professor Carlos Fernandez is going to throw around
It's going to
some.
be an excellent presentation, that one.
And I honestly, I know this is being recorded, and I think that this is one of his last because he's retiring. So it's up for students to become academics, to carry the torch, to be able to talk about what happens in Miami next. So you're definitely on your way with these presentations.
And he's an excellent presenter.
As were the presentations today. Was this the last session? Was this the last presentation?
Yes. This is the last presentation for today. And I think the students did a great job in this interdisciplinary activity. And so they extended because the class typically ends at 4:45.
Right.
So we are about 1 hour later, so they may have other commitments.
Yeah.
And actually, I really commend their work and their commitment to be with us here. And
Likewise.
the integration of disciplines.
I'm sorry if my comments drew this out, but I want to thank whoever's still in the room, even those people who might not have logged out, who might just have left their
it's
profiles
recorded,
here.
so they may watch it and replay later on.
Good.
So it's one interesting point, correct? Thank you for your contributions here, students, and thank you, Mark, for coming. And I just want, if you have pointed how to get involved in this one, how to get more information in this one, and I am pretty sure the students have got that information and keep on working on that. Some of these presentations may be polished a little bit more to be presented in March in the campus symposium.
Oh, good, because we're going to continue with this topic.
Yes.
So if you want to pick up with this with your next classes, definitely do it.
Exactly. That is the point, to continue.
I'll put in the chat some links to if you want to stay in touch with the Earth Ethics Institute or anyone involved with change making at MDC. Again, my name is Mark Turpak. I'm with the Drone campus, but I'm happy to try to connect with you via email or this, like online. However, if you want to discuss these ideas more or have ideas that you want to share or things, just let us know.
I'm pretty sure they have a source. Correct. Good. And they like the league guys and all the work that Steve Cronin have done also as well.
Oh,
and
Steve Cronin.
Yeah.
Perfect.
He's also retiring, but he is leaving his legacy here in the Earth Ethics Institute. Anyway, okay. So I appreciate everybody. Mark, we're going to get off now. Okay. And thank you for your presence here. And thank you, everybody. Lianette, you have a point? You want to say something, Lianette? Lianette?
You might have to unmute Lynette's microphone. I don't know.
No.
Maybe not.
I did not mute anybody. I did not mute anybody.
Okay.
I don't know. Maybe she was leaving or something like that. Lianette, maybe she clicked it. Lianette, do you want to talk? Let me see if she has something in the chat. Lianette, Maybe she was trying to.
Professor,
Yes, Ryan.
I'm pretty sure you have to put him as a presenter since those are the people who could talk.
Oh, okay,
Yeah.
okay, Leonette, let me.
Lynette, I just put you as a presenter. Do you want to try to say something?
Okay, try. Put her as a presenter, please.
Hi, hello, Professor.
Hi.
Hey,
Tomorrow
how you doing,
I'm
Leonette?
good, and yourself?
Fine.
Tomorrow I'm
Leonette.
presenting with gender inequality, and I just wanted to know around what time is the slot, because I looked at the schedule and it didn't really say.
Yes, Leonette is from 8 to 9 only the time frame. I don't have the schedule of the different presentations, but I know that it must be between 8 and 9 a.m.
Okay.
Correct?
Okay, thank
It
you so
will
much,
not
Professor.
extend from there, Leonette.
Okay.
And if there is not enough time, the ones that can that have some work done on that may interact by using the Q&A session that will be there. Correct?
Okay, thank you so much, Professor. Have a good day.
My pleasure, Leonette. Thank you for coming today and for participating today here. I know that your group did a great effort in gender inequality as well, and you have a presentation that is awesome. Mark, because we had beyond the climate change, we have another two topics in campus with the global initiative. We have gender inequality and we have infrastructure.
Oh, interesting.
And those two activities are going to be presenting tomorrow in the frame of this global initiative in the campus.
Oh,
so
fantastic.
I try to connect and put that in the context of this situation. So for that reason, she was asking when is hers
No
tomorrow.
worries. Well, it's definitely of interest. It all relates. I mean, and it all relates back to this year's theme of health and well-being.
And as part of a change makers, they can do something also as well in the sustainability and the of the society as well, because it makes influence. Correct? Maybe women with their impact can do something better in climate change now in this century. You know, the participation of a women, and we can see many presentations that have shown how difficult are the inequalities that they suffer in different areas, not only in the salary, but in the social society in general. Still, we have that problem. And the infrastructure is something that we are pointing at because together, the climate change, we need to increase our infrastructures nationwide. And so there are some presentations related to that. Okay, so Mark, anything else? Okay.
Nothing from me. Good luck tomorrow, Leonette. Good. Congratulations to all the students who did present today.
Yes.
Good luck with your studies. What a good group. I mean, it's. I feel in good hands, even if we're all floating together in Miami. We'll be okay.
They are going to support us in the flooding.
I will need it.
The success is from them. The students made this possible with their hard work. Okay.
Okay. Well, thanks everyone. Bye. Have a good evening. Bye.
Take care, everybody. So you did a great work together, and I will let Dr. Mahmoudar know that as well.
Thank you.
Take care.
Thanks, Professor.
Bye-bye, everybody.